Right, grade 11s, when we are presented with a surd equation that looks complicated, like the one that we have here, where in the surd, you see there are a lot of variables. There's actually an easy way to approach this problem. And the approach that we take is to use the K method. Now, what the K method does is you just substitute K in the place of the surd. So wherever there's a surd or a square root, you substitute the variable K. So what the K method does essentially is it just simplifies the surd equation and it makes it so much easier to work with. So if I'm to substitute a K wherever the square root is, the equation would look like this. And if we are to do a comparison of equation 1 and equation 2, it is quite evident that equation 2 is a far more easier equation to work with. So let's solve for K. And in turn, when we can find K, it becomes easier. It becomes easy to solve for X. So first thing to do is to multiply by K throughout each term. Multiply each term by K. Why we do so is because we want to eliminate this K here. So if we do that, we'll have K times K minus 3 times K over K is equals to 2K. Remember, an equation is like a scale. What you do on the left side, you do on the right side. So K times K is K squared. This K and that K cancels out. Minus 3 is equals to 2K. So what we're working here with essentially is we're dealing with a quadratic equation because we have a square in the equation. So let's write this in standard form. K squared minus 2K minus 3 is equals to 0. So factorizing this should give us K and K minus 3 plus 1 is equals to 0, because the product of these terms gives us that. Positive 1 times minus 3 gives us negative 3, and the sum of these terms gives us the middle term. So these factors are correct. So by inspection, K cannot be equals to negative 1 because a square root or a surd should always be positive. So therefore it implies that K should be equals to positive 3. So reverse substitution tells us that K should be equals to 2x plus 5. And remember, the square root of any number should be greater than 0. That is why we rejected the first solution. So now we can just substitute 3 in the place of K. So 3 should be equals to square root of 2x plus 5. And if we take the square on both sides, remember the square and the square root cancel each other out. So you take the square there, we should have 9 is equals to 2x plus 5. Therefore, 4 should be equals to 2x, which implies that x should be equals to positive 2.